welcome to my YouTube channel. I'm going to talk about my project. My project is about analysis of global terrorism dataset. In this article, analysis conducted on global terrorism data from two different contents are compared. The main purpose of both studies is to determine the patterns of terrorist attacks experienced worldwide and to predict types of attacks or target types separate using various options. However, the interventions use tools depth of analysis and breadth offered are remarkable. Both studies conclude that terrorist attacks have analyzable patterns. Data mining algorithms can make prediction by learning these patterns. Among the classification models, neural networks algorithm generally gives the best results. We have a lot of algorithms to use in this case. First one is CVM. CVM support vector machines, we call that. What does it do? It works in the best region, separating different classes from each other. This limit maximizes the distance between classes. Where is it strong? In low or medium-sized dataset, if there are clear linear separation, weakness, training time increase. In large dataset, performance may decrease if there are too many classes. And naive-Bayes. Naive-Bayes, it uses Bayes' theorem, assuming that the features are independent of each other and calculates the probability for each class. And I told KNN. And natural networks. It transfers information between layers and quantities by imitating the human brain. Each layer learns the data, and it is suitable for achieving high accuracy in large and complex datasets. The weakness of natural networks is the training process is long, requires a lot of data and processing power. Also, there is a risk of overfitting. And confusion matrix, complexity matrix also. Confusion matrix, general structure of confusion matrix, it shows how accurately a program predicts with four different categories, like true positive, true negative. False positive, the model mistakenly said yes. False negative, the model mistakenly said no. And I want to explain this. True positive, true class is positive, the model predictive positive, correct prediction. True negative, the true class is negative, the model predicted negative, correct prediction. False positive, true class is negative, but the model predict positive, incorrect prediction. False negative, true class is positive, but the model predicted negative, incorrect prediction. Also metric measurements sensitivity. It have a formula, TP plus FP, shows how many of the positive after prediction are truly positive. Recall, show how many true positive were predicted correctly. And also FP have a formula. We can see that here. And FP score a non-standard feature of fraction and recall. An area under the ROC curve, the general success rate of classification modeling is between 0 and 1. The closer is it 1, the better. And we can continue. We have a comparative analysis of algorithms. After doing comparative analysis of different algorithms on prediction and recall value and target value set to be attack type, KNN, CVM, neural network, naive-Bayes, we can see projection recall, FBIR. KNN is bigger recall than CVM. We can say that from the table. And we have a Python code with dataset. The results are here. KNN, CVM, naive Bayes. Those are algorithms that we use. And KNN F1 score, F1 score is middle of the CVM and naive Bayes. And we have dataset link. And we have seen KNN confusion matrix and rock curve. A table showing the classification success of the actual versus predict data. The area under the area values were calculated. And we can see here CVM rock curve, naive Bayes rock curve, and also confusion matrix for naive Bayes and CVM. We can say for the results, in the results section of the article, the program used are compared for different target values. Prediction is made on two targets as attack type and target type. Confusion matrix, precision recall, and FB score values are compared for each opening. According to the results, neural networks generally show the highest rate and provide the highest accuracy. Naive Bayes provided lower accuracy despite faster work, and KNN and CVM provided mid-level success. In comparison, my work may focus on evaluating this algorithm and determining the classifier that give the best results. The article compares this algorithm with metrics such as accuracy, precision, recall, F1 score, and AYC, and indicates which algorithm is the most suitable for which target variable. For example, you can say that NNN gives the best result for attack type. In addition, the confusion matrix outputs of each algorithm are presented in a table. And also my study aims to compare classification algorithms on the global terrorism dataset in general to find the most appropriate prediction model by comparing the accuracy of these methods. In other words, the focus is on the comparative performance analysis of data mining algorithms. And the shared article, on the other hand, uses the same dataset but provides a multiplicated evaluation by making prediction with both visual analysis and classification models. In addition, the article explains why the study is important in a social and psychological context. Thanks for listening me. I hope you will like my project. Thank you.